That rude video cutting me off like that. So here were several of my options that I had listed on the previous screen. So taking the cosine inverse, of course, when cosine is 0, I get all these values that I set it equal to in red. And then when I solve, these are the values that I get. So I get a negative 3/4. Can I keep it? I can. It's in the interval. I get negative 1/4. Can I keep it? I can. It's in the interval. Positive 1/4. Can I keep it? I can. It's in the interval. Positive 3/4. Can I keep it? You can. 5/4. No, you can't. It's not in the interval. So I get 4 values where the slope is 0. Kind of makes sense if I look from negative 1 to 1 at this sign. And if I graph it correctly, then you would see, oh yeah, I'll have a slope 0 here, 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 and here between negative 1 and 1. So again, I want to check to see whether Rawls' theorem can be applied. And so I check. Ooh, I have to think about what this graph looks like. Retro. I think there's a vertical asymptote right at 0. Uh-oh. You know what that means? It's not continuous. That's good because I spelled it wrong again. I'm missing an extra U. So as soon as it's not continuous, Rawls' theorem doesn't apply. Remember, it says if so, so it's a not, so I even spelled theorem wrong in your notes. Huh, never noticed that. Doesn't apply, and I hope they give me a whole bunch of these problems because I don't have to do anything. Do nothing. So in order to apply mean value theorem, I don't have to worry about whether or not the y values on the endpoints are equal. I just need to worry about, is it continuous, is it differentiable, is it closed? So of course I'm looking at a cubic if I distribute that, x, right? So I have a cubic polynomial. So yes, it's continuous on negative 1 to 1. It is closed, right? It says closed from negative 1 to 1. And continuous on negative 1 to 1 because polynomial curves are continuous. And then differentiable, well, since it's continuous and I'm thinking, oh, you know, I have some sort of crazy cubic, then it would be differentiable as long as I don't include the endpoints. So on this negative 1 to 1, I'd have to have an open circle at negative 1 and an open circle at positive 1, and then it's a yes. Okay, so then I have to figure out all values so that when I take, instantaneous rate of change, I think I know how to do that. You know what I'm going to do though? I don't want to have to do product rule. Shoot, I'm going to distribute this so that I can just use power rule because I'm smart like that. So my first derivative would be 3x squared minus 2x minus 2. And so that's the instantaneous one. And then I want to find f of b minus f of a over b minus a. So I got to stop long enough to do f of b. So f of this is b and this is a. So f of 1 minus f of negative 1 over 1 minus negative 1. Right? So all I'm doing is just plugging these numbers directly into that formula. And so f of b, if I did my simple arithmetic correctly, would be negative 2 and minus f of a. So remember a was negative 1. So I did f of a, which is 0, all over. And so b minus a, that's going to be 2. So I'll have negative 2 over 2, which is negative 1. So keep in mind, I just found what this right side equals. It equals a negative 1. And so I want to figure out where my instantaneous slope, that's this formula here, is equal to that. OMG, I have a quadratic. Pause and see if you can solve for x. So I got 2 answers, but I got to go back and check what was the interval I was hunting around for it in. Well, it was the open interval from negative 1 to 1, so I can't keep that, but I can keep the negative 1/3.